Hey everybody, back with another video. I've been actually working on a different Space Invaders board, and I decided as I'm waiting for some RAM to come in for that other board, I would put this other one on the bench here real quick. One thing to notice is this board is kind of bent. It's almost like cracked right here, but I don't believe it's actually impacting a trace, but eventually it could. If I come on this side, you can also kind of see it right there. So I don't know what happened right there, but could be a problem. I don't know. I haven't even ohmed it out to see if that is the problem. But what I figured I'd do real quick, and let me sit down here. Alright, what I figured I'd do real quick is hook it up to the Fluke, power it on. All we get is a white screen, which is not normal. Let's run our setup. No, stop. Run unit under test. We should get some lines or something going on here, but you can see it looks like it's trying to draw some lines, but the white screen, that's weird. I don't know. So let's go ahead and hit stop there, and let's do a bus test. Bus test is okay. We're going to do a RAM short 2000, enter 3FFF, enter, and we get an error right away, a read-write error to address line 2000 BTS 80. So I'll figure out the hex of that real quick. But let's go ahead and hit continue. 2001 BTS 80, 2002 BTS 80, 3, 4, 5, 6, 7, 8. Alright, so we're getting BTS 80 on every single address line. So that means we can't read or write or activate that data line. And so let me figure out the hex real quick for that and come back. Okay, so based off of the last video, we know that the hex of 80, that bit mask, is 10000000, and this is basically data line 0, 1, 2, 3, 4, 5, 6, 7, and we know that this I showed this in the previous video, but this is this grouping of chips. One bank operates on even address lines, and one bank operates on odd address lines. But there's the same data line is shared between these two chips. So like data input should have continuity on this two chips, and data output should have continuity in and out. Same here, same here, same here, same here. It's just a matter of which one's being addressed. So in data, I think it's pin 6 and pin 7 on each chip. Pin 6 is data in, and pin 7 is data out of these 2107 DRAMs. So I kind of am backtracking a little bit because I already looked at this the other day, and I wanted to show you guys how I figured it out. The problem is, but let's go ahead and loop on that. So we're looping on trying to, read write to that address. And if we grab our scope, so I don't know if I covered this, but we know that it's data line 7, and I know that that's this pair of chips way up here, these two up here, which is somewhat difficult to see. So if we come to 1, 2, 3, 4, 6, that's what the data input looks like on a good working chip. And if I come to 1, 2, 3, 4, 5, 6, this is on data line 7, you can see there's nothing happening there. That's the that's the input of data line. Whoops, what did I just do? Okay. 1, 2, 3, 4, 5, 6. That is the input, and nothing's there, right? So then what I did is I traced that back to B3 pin 12 and pin 14. So from the CPU, it goes to these two 8216s, and that's, I guess, I don't know what the 8216s are. Are they buffers, I guess, or something like that? I think they're buffers. But I don't know. But pins 12 and 14. So this is this should be 8, 9, 10, 11, 12, 13, 14. And I'm not getting anything there. Let me see what this other one is. That is C. Am I looking at the right chip? I think I am, yeah. Let me come back. Alright, I thought I did it more scientifically, but I guess I just came and looked at the schematic and wanted to see what the data input line, so line 6, was tied to and how it got onto the data bus. And first it went to this 330 ohm resistor here, and then I looked up here and I could see this resistor is broken, is not tied. So my data line is not tied to the resistor that then goes to eventually, I guess, whatever these 8216s are. So I know that's my problem. I can't remember exactly how I got to that, but I was just probing around and trying to backtrack. Okay, where's data line 6 broken at? Because I thought maybe it was something to do with this little break right there in that area, but I just saw that little resistor there, and that ends up being the issue. So let me fix that and come back. Alright, so I put that resistor in. Let's see what we get. I think there's more problems than this. Yeah, because I just have that white screen, and that's not what I should get. But let's go ahead and do a RAM short or stop. Sorry about that. Bus test. RAM short 2000, 2 clear 3 FFF. Enter. Alright. Now this is better. We know we can get to RAM. Now something else is going on. Sorry, that cable's in the way. So our RAM looks probably good. Just waiting there. So we got some other issue, most likely. We have to have good clock. If we didn't have good clock, the bus test would have failed, I believe. And we shouldn't require any ROMs being in there for this board to work. I might check the power to all the RAM chips real quick as I wait for this RAM test to finish. It's a long time. I might check the power just to make sure I'm getting good power. -5, 15. Well, I have to be. Otherwise the RAM would be failing. So I don't know what that white screen is. Alright, I'll pause and come back. So it says our RAM is okay, which is good. But I think we have something going on with our video output. So let me look at the schematic there and figure that out, because it definitely shouldn't just be a white screen. I should have lines on the screen when I don't have any ROMs there. Alright, so this is the schematic here, and basically if I come, let's see here, all the way over here, our video 18 comes all from here all the way over here like this, keep coming to this 10 microfarad cap right there, and then it gets tied into this line that goes all the way up to these two 1K resistors that come into a 7432 at AX, pin 3 and pin 6. So let me come right back. So there's our video right there of the game board powered up. There's our video. It comes to this cap. The positive side of this cap comes to these two resistors here. Here are the two 1K resistors. I measured those. But if you look at, and by the way, I have it on, and you can kind of see I'm running unit under test, and you can kind of see the white lines vertically. I know that's kind of tough to see, but you can kind of see the the lines, except for it's all white. And if I come to pin 6, that's what we look like on the scope. 15.5 kilohertz, and it's going all the way from 0 to 5 volts basically, the signal. And then if I come to pin 3, 1, 2, 3, that's what our output on 3 looks like. And pin 2 is low. I don't know what a 7532 is. So I think that's our problem. I don't think that it should look like that, the 7432. So I'm going to see if my comparator shows it bad. Alright, I have my little logic comparator. It says pin 6 is bad. 1, 2, 3, 4, 5, 6. Pin 6, the output there. I'm going to look up what a 7432 is. I don't know off the top of my head. Yeah, 7432, it's a quad, 2 input, positive OR gate. So if either A or B is high, the output should be high. And it's interesting that pin 6 is showing as bad when I suspected, based off of just looking at the scope, pin 3 would be bad. So let's look at pins 4 and 5 here real quick. I'll sit down. Alright, so here is, that's pin 4, and it looks like it's low all the time. It looks like it anyway. And then pin 5. Oh yeah, so that does make sense. And here's pin 6. So pin 6 looks just like pin 5. I don't understand why it would be bad. That's low all the time, pin 4. Pin 5, when both are low, it'll be low, otherwise it'll be high. Pin 1 is not quite high. I don't know what's going on there. Pin 2 is low. Pin 3, that kind of makes sense, but I wonder what's pin 1. Why is pin 1 not doing anything? I'm going to look at the inputs as well, but I don't know. Something seems like it's jacked up. Maybe I'll piggyback something real quick. I cleaned up the chip legs a little bit with an eraser, and then I hooked it back up with my comparator. My comparator says that 7432 is good. So I'm thinking it's got to be something on the input side that's messed up. Okay, so the inputs to this 7432, or at least the one I'm concerned about, which is pin 1. Let me review. It's pin 1, and that's the voltage I'm getting. Just barely. It's not doing anything except for maybe 1.68 volts. And that goes to pin 13, which is right there. And that is C4. And there's a whole bunch of RAM data inputs coming into this thing. Like, I know you can barely, no, you can't see that. Let me zoom up here. That doesn't look great. I'm not going to adjust it, but I'm just kind of showing you some different inputs here. So some of them aren't getting very high on the voltage. There's a date. This is all data outputs from the RAM chips coming into this shift register. So some of them, you know, look better than others, obviously, but I don't know exactly how high they're supposed to get. But one would think that there's, I don't know, I'm going to put my logic comparator on this and see if I can verify if it's bad. It doesn't look great. I mean, I would think something should be shifting and pin 13 should be doing something. Yeah, so it definitely put it in my logic comparator. It definitely shows pin 13 as being bad. I mean, doesn't mean that it's bad, but I think we're on to something. Let me go ahead and swap that out. Alright, I have the 166 replaced. I don't know if that was the issue or not. It could have been just corroded legs not letting me get a good logic comparator reading on it. And that looks like that might be the case because it's still white. Yeah, I'm still getting white screen. Interesting. Yeah, I don't even, doesn't look great. Sixteen, 15, 14, 13. Something is not right. Alright, so my logic comparator is reading that chip good now. So assuming that that was part of the problem, I'm not sure. But I'm still have a white screen, which isn't ideal. And I'm starting to get RAM errors now, which I wasn't before, which is kind of strange. Let me just RAM short 2000. And it seems to be consistent. So this is address 2007 and bit 28. Alright, bit 2007, so that's odd. And 201F, I don't know if that's odd or not. 201F, 202F, 35, but it's all bit 28, and I think 28 in hex, let me just see. No. In hex, it's this one. This is a 1, so it's 0010100. So this is data bit 012345. Those two data bits are consistent. I just have to look up to see if there's consistency of odd or even with 201F, 2F35, I'm not sure. Almost went down a wrong path. I don't know. I just reseated everything. Maybe the board is warming up. It is slightly cracked there. I don't know if that's a problem, but now it's passing the RAM test. But it still looks like crap, so I'm not sure what the hell's going on here, but I'm going to compare my inputs. My inputs right here, which are RAM data lines on pin 14. No, that's pin 14 right there. Let me increase this. Alright, that's pin 14. If you can see that. And then pin 13 is the output. That's the output, which is just low. It's not doing a damn thing, which is better than what it was before, but it's still not working right. Then there's data line 1, data line 2, data line 3. Pin 9 is high, which is VRA, and I'm not sure what that is yet. Pin 1 is grounded. Pin 2 is data line 7, which obviously looks ideal to me. Now that's data line 6, which I don't know, it looks kind of odd to me. That's data line 5. That one's kind of weird. That's data line 4. what, I don't know what pin 6, 7, and 8 are. 6, 7, 8. Let's check out. Let me look at what 6, 7 6 and 7 are our shift and load, I think. And let me put this on frequency. Crank this bad boy up a little bit. About 5 megahertz. Both signals could be the same or the opposite of each other, but just pulsating at 5 megahertz. So shift and load looks good. That VRA, I don't know if that's supposed to be high or not. I'm going to plug in a different board and see what VRA looks like and what some of these data lines look like. This is the other board, just to keep you guys up to date. And I was just looking around. Now, granted, this one I'm waiting on memory for, but if I come to pin 15, I have about 500K, you know, frequency of a signal there. Let me adjust this a little bit. Pin 15 right there. And I'm not sure, I have to look up what the heck is pin 15, but I don't remember it doing that on the other board. That looks like might be our, at least most of our problem, that pin 15. So I'm going to hook up the other board and look at pin 15 again of this 166. Yeah, that's definitely a problem. I'm looking at pin 15 and it's just high. And that, let me trace that. I think that comes from A7, pin 8. A7, which is right here. 1, 2, 3, 4, 5, 6, 7. Pin 8. Pin 8 is high. Pin 9 is low. I don't know what's going on there. Let me investigate this as a 7404. See what's going on with that. Maybe that signal's not coming in. Alright, coming back to the 74166, which is a 8-bit shift register, parallel load, it says. I don't even know what that means, but 6 and 7 are basically clock inhibit and clock or something, so I don't know. I'd have to read exactly, try to figure out what this is due. But regardless, that clock looks good. We got 5 megahertz there. But what we do have is, I was wrong about 6 and 7 being shift and load. It says S and L on the diagram schematic, but here that 15 is the shift and load. If 15 is not toggling, this chip isn't doing jack crap. I don't think. So I traced that back to D6. No, D6. And I do have good continuity there, but don't see anything, any signal. It's just low. So I need to figure out what D6 is, and it's hard for me to see. So I'm gonna have to look up that chip and see what the heck's going on. All right, I was tracing things back and not filming everything, but I think I'm on to something. It brought me to pin 15 of these 9316s here, and it's just dead as a doornail. And I went ahead and hooked up my logic probe just to make sure, and it's low. And if I come, I think this is a 9, 10, 11. This is a counter. This is a like the equivalent of a 161. That should be toggling. That should be toggling. Yeah, I mean something's jacked up. Like here's another one right here. All of those should be toggling, and they're not toggling on any of these chips here. And they look terrible. And if I can zoom in and up, like close enough there. There you go. It just looks really bad. I'm going to cut those out and replace those. Alright, it could still be messed up because it took me a while to actually clean these up. I think those chips were replaced before. It looked like crap. Stuff was all heated up. This one was better, but this one I had to do a couple of jumpers. Anyway, I don't know if they're 100%, but I think they are. So let's power it on. Alright. Well, it's definitely better. I don't know if it's right, but it's definitely better. Those aren't, you know, that's not normal lines there, but let me see. Grab my... Let's look at pin 15. It still looks bad. What the hell? So I might still have some issues here. Oh boy. Yeah, something's jacked up. I don't know, it's better, but I don't know what's going on. I have to think about it, probe around. I don't know if I have all the pins are making contact. I gotta check my frequencies there on those counters. Alright, I've been messing with this for actually a couple hours or more, I'm not sure, but I went ahead and looked at my 8080 guide here, the clock troubleshooting section, and everything looks pretty good. I mean, the references that they give you, like here, might be for an older 8080 game. These frequencies don't match up. I went ahead and recorded the frequencies from my other Space Invaders boards for the counters, so the 9316s or the 74 161s. And the issue is my vertical section is totally jacked up. E6 and E7, those counters are not working. And if you look at the schematic, hopefully you guys can see this somewhat okay. Let me see. Yeah, E6. Basically, I went through and checked all of these pins for the most part. I did find an issue on E7. Pin 4 was not connected to... Was it pin 4? Yeah, pin 4 was not connected to pin 9 right there. If you can see that. So right there. And that is coming from this A5. So I temporarily put a jumper in there to fix that. But the other issue is the load. It's like it's a loop here, right? It's like a self-fulfilling prophecy kind of thing. I don't know. But E6, you know, the ripple carryout goes to E7 on pin 10, and then based off of its inputs, you know, it has its ripple carryout, but its ripple carryout actually feeds this inverter over here. I think, what is it, a 7404 or something, hex inverter. And then that goes into A5, which then feeds the input. So and that also is the load for E6. So like, this is dead. And without this whole loop working, neither of these chips are going to work. So I went to look at this A7 chip, and it just looks bad, and I'm probably going to replace it. Let me see. That's the best thing I can do. I tried clipping the one leg, pin 13. Is that right? Yeah. Pin 13, which comes from the ripple carryout over here. It's actually also where I had to put my jumper. And I don't know. I'm just hoping that this chip is bad. Even with the comparator, I couldn't figure out that it was bad, because based off of the inputs, the output was fine. It's just an inverter, and there was nothing on the input. It was actually it's just floating. It's not low or high. It's just doing nothing. So I'm going to replace this and come back. Alright, I replaced this, did a decent job pulling it out, and let's see here, but then I still wasn't getting anything, so I was using my logic probe, and the output pins, pin 15 was still dead. It was like floating or something. It wasn't activating. So I was like, all right, maybe I have a bad 74, a bad 161 here. So I swapped out both of those, and I got some better results. I'm not doing it right now. I tried, but this one, so these two, let me see. I know it's kind of difficult to see, but there. Could just get it on the tripod, I know. But these two seem like they're bad. I'm going to test them here in a second. And then I put this one in, which is a brand new one, and I realized that there was continuity between pin 15 and 5 volts. Like a couple of the pins were shorted. So this is also brand new, and that one was bad, which is crazy. So anyway, I'm running out of battery or something, but it looks like I have good clock now. I'm going to put it on the scope, but I think my clock is good. Everything's toggling. All my outputs are toggling where they weren't before. So, alright, let me clear the memory card and hopefully you can see this. I have my TL866. It's actually got new software, which is actually kind of nice. And I am going to test a few 74 161s. And let's test these. And you can see that failed. Yeah, I mean, you see all the red there. It runs it through all its vectors. And that is bad. And so I think I grabbed two bad. There's another one that's bad. A couple more were normal, but looks like most of the vectors failed, the test vectors. And let's test this one. And then, I don't know, hopefully you can see that. It says test failed over current protection. So that is the one that was shorted to the 5 volts. I actually almost want to verify. I'll test these. Alright, that one's good. So I have two good ones that I'm actually going to put in there. So I guess I should start testing chips before I use them. I mean, that kind of sucked. I think I ended up, replacing other things I think were bad too, but let's go back to the bench. Okay, so I put in my Brazington kit, and I'm going to power it on. Actually, I guess I could take this out. Let's see what it looks like without it. The other thing is, I didn't have, part of my issue with that you were saying is I had external sync enabled on my PVM, and I needed to have that off. But let's go ahead and power up. Alright, that's what we're getting there. With no CPU in, that's what I'm getting. That's with external sync enabled, and that's with it not enabled. Let me power it off and power it back on. Now with a CPU we should have some solid lines, but we're going to go to pin 15. Got a frequency measurement on here. Actually, we're going to go to pin 11 of E7. 9, 10, 11, and we should have 60 hertz. And we basically do. And if I come to my two resistors, this one we were getting, I think, 15 point something K. You can see that. By the way, I adjusted my meter because on my graticules, I never knew this. It says 0% way down here. And so if I have my volts per division correctly, I'm using 10 times probe with 1, it'll go all the way up to, 5 volts should go all the way up to 100%. So if I come to like a 5 volt, you see it right there. almost 100%. So 0% is ground. So I basically adjusted my graticule, but and then there's pin. What am I doing? Pin 11, 60 hertz right there. And then 120 hertz, basically. And then double that, 240, from 120 to 240. And then the 480. And then 960. So I know my counters are working correctly now. So let's go ahead and put. I'll come right back. We'll put in the Brazington kit installed. Here we go. Looking good. And something's going on. I'm missing a 0. ROM okay. I think everything's okay, but some graphics issues. Yeah, definitely some graphic issues going on. Alright, let me go ahead and start a game. Got sound. No shots. I got 2 ships. And they're invisible. So we got sound issues. But I'm gonna go ahead and stop the video here, and we'll make this part 1. We'll make this part 1, and then I'll come back and do part 2 to fix the graphics issues, and maybe part 3 for the sound. All right, that's it, guys.